Another method of solving that we can use is called completing the square. And this is going to come from our perfect square trinomials and how it nicely factors into this perfect squared like x plus 1 squared or x minus 1 squared. So what we're going to do here is just fill in the blanks and kind of see the relationship between three pieces here. Three pieces we want to focus on is what's showing up in the parentheses, what's showing up for B, and what's showing up for C. So let's see how this works. So in terms of foiling, again, if it helps, you could think of this as the expanded x plus 1 times x plus 1. The value for C is going to come from those last terms multiplying each other, which in this case is going to be 1 squared, which is just 1. In the next case, it'll be 2 squared, which is 4, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. So you can see these perfect squares coming up in that spot for C and how it factors nicely into that perfect square. Now if we have subtraction, it looks pretty much the same. And again, if we think of the expanded, we'll have minus 1 times minus 1. So it's always going to end up positive. So that's why we always have plus in that right column. So really we're just thinking of 1 squared. So the spot that really changed here was with B, we see a negative symbol. So that would tell me if we factored, we would see subtraction in the binomial. 16, 25, 36, 49, 64, 81. Okay, so let's take a look at the relationship here between those three pieces I was talking about. Let's go ahead and look at these larger numbers. So I can see I have a 6 there, I have B of 12, and C of 36. And let's kind of focus on that B is 12 here. Well, if B is 12, that means when we're factoring, we're using half of B. So this value is coming from B divided by 2. And that's true for all of these, where we have B of 14, B of 16, B of 18. The value in the factored form is half of that. And then what we're adding up at the end for C, where that's coming from, is taking B divided by 2 and squaring that value for each of these. So with that idea, if I start with my value for B, I can get an idea of if I have like B of 18, then I would want C of 81 in order to make it a perfect square. I know that by taking half of 18 is 9, square it, that's 81. If I have B of 16, take half of it is 8, square it, I would need that 64. So this is the completing the square part. We're going to complete the square by adding on these values, by evaluating B and taking half of it and squaring it. And by completing the square, we're going to get something that's very nice to factor. And then we'll go through solving. So the term that completes the square for a polynomial x squared plus bx, the constant term that we need to make it a perfect square trinomial is b divided by 2 squared. So let's see how this works. So what I see is on the left-hand side here, I have x squared plus 10x. And then I have equals 24. Now if I move that 24 over, it's not going to be a perfect square. Maybe I could factor it and solve it. That would be great too. But let's focus on completing the square here. So what I'm thinking of is I have x squared plus 10x. What I'm missing on the left-hand side is a value for c. On the right-hand side, I have 24. So if I want to complete the square, what I'm thinking of is, okay, I want to take half of 10 and square it. So 5 squared. So I'm missing a value of c of 25. So what I'm going to do is add on 25. But whatever I do to one side of the equation, I have to do to the other as well. So x squared plus 10x plus 25, I now made that so that it's a perfect square. So I can factor that as x plus 5 squared equals 24 plus 25 is 49. Now what we have is something squared equals a value, and we can use our square root method that we talked about in the last video. So I could go square root. So on the left-hand side, all I'd have left over is x plus 5. On the right-hand side, plus or minus, very, very important, square root of 49, 7. And then not my last step, I always do that, I kind of rush ahead. I'm going to subtract 5 from both sides, and it's best to write this number out front so that the plus or minus is between the values. So I'm going to have negative 5 plus or minus 7. So that I get my two solutions. Negative 5 plus 7 is a positive 2. Negative 5 minus 7 is a negative 12. And there's our two solutions. Let's get some more practice with these, but with completing the square, we're just adjusting it so that it's something that's really nice to factor, and then we could use our square root method to solve. Okay, y squared minus 20y minus 5 equals 0. Ooh, sorry, reading got hard there for a moment. So what I want to do is I want to move that negative 5 away from everything because I just want my ax squared plus bx on one side of the equation. So what I'm going to start with is adding 5 to both sides so that I just have y squared minus 20y, and then I could think about filling in the blank for what I want to add to complete the square. And then 5 is on the other side of the equation, so I don't need to worry about any extra numbers hanging out. So to the side, I'm thinking of 20 divided by 2 and squaring that, which is going to be 100. So I want to add 100 to both sides of the equation. And when I do that, that makes it very nice to factor. So I'm going to have y minus and then half of b, so that's going to be 10, equals 105. And then I'm at a spot where I can take the square root of both sides of the equation. So y minus 10 is equal to plus or minus the square root of 105. Add 10 to both sides, so y is equal to 10 plus or minus root 105. And that'll do it. We could leave it just like that. If we're working with a word problem, maybe we'd go and get decimals so we could see some more exact values, but this format works great. Now, something that's been going on with these I haven't explicitly pointed out is that we don't have values for a here. There isn't anything multiplying outside of the x squared or the y squared here, and that is important in terms of our factoring here, of getting our complete squares and our perfect square trinomials. So when there's a value out front that we can't easily get rid of, that's when we might opt for factoring, or what we'll look at in the next video is our quadratic formula. Okay, let's keep going with two more examples here. So I have x squared minus 6x, and I want to add on whatever will complete the square. I have 16 on the other side. So completing the square, I'm going to have negative 6 divided by 2 for negative 3. Squaring that is showing me I need to add 9 to both sides. So that'll factor nicely to an x minus 3 squared. Again, if you're not sure of the number that shows up in the factored form, you're just looking at the inside of the parentheses there. So negative 6 divided by 2 gives us that negative 3. 16 plus 9 is 25. Let's take the square roots. So we're left with x minus 3 equals plus or minus the square root of 25, which is 5. So x is equal to adding 3 to both sides, so we'll have 3 plus or minus 5. And with these, because they're whole numbers, I go a step of simplifying them into a single value just because we can combine like terms here. So 3 plus 5 is 8. 3 minus 5, negative 2. All right, one more example here. So I'm going to move the 6 to the other side of the equation. So I just see m squared plus 8m, and then we can add on something to complete the square, equals a positive 6. So again, I'm thinking 8 divided by 2 is 4. Squaring that, I'm going to need to add 16 to both sides. So that'll factor nicely to an m plus 4 squared, equals 6 plus 16 is 22. Square root of both sides, so we get m plus 4 out of those parentheses, plus or minus, and we're just going to leave this as a root 22. Subtracting 4 from both sides, so I'll have a negative 4 plus or minus square root of 22. So there's our completing the square. It takes just some practice with these to get comfortable with it, but it's a nice method of solving that kind of helps us, especially when we get to the next section with quadratic formula. It's a little more direct than quadratic formula, but you'll kind of find the method that you prefer and go with that with solving quadratic equations.